So in today's video, we're going to talk about the area of a sector, or the area of a sector of a circle. So it says that, recall that when we find the area of an entire circle, we use the formula A equals pi r squared. Well, a sector of a circle is similar to a piece of pie or a piece of circular pizza. So I'm going to highlight that because I know there's some highlighters out there and I think it's important. And it says when finding the area of a sector, you're actually finding a fractional part of the entire circle. And that's important. So you're finding a piece of that circle, the area of that piece. The fraction is determined by the ratio relationship of the central angle of the sector and the entire central angle of 360 degrees. Or by the ratio, and this is important, we're going to see this later on, or by the ratio of the arc length to the entire circumference. It's easier to remember that you are dealing with fractional parts. All right, and it is. And I think back in your middle school days that you discussed something, and we're going to use part to whole equals part to whole. Well, that part's going to be that angle over 360, and the part's going to be that section that you're trying to find, or that sector, over the whole area of the circle. So let's dive in. Let's take a look at number one. Number one says, find the area of a sector with a central angle of 60 degrees and a radius of 10. Express your answer to the nearest tenth. All right, so we have our circle here, and we have 60 degrees is our angle, and we're trying to find the shaded in region, the area of that sector. Well, we know that. Let's first find the area of the entire circle. So area equals pi r squared, and we know that the radius is given to us is 10, so that equals pi times 10 squared, or that equals 100 pi. So that is the full area of our circle. All right, now what we're going to do is we know that the angle measurement is 60 degrees, so we're going to set up our part to whole equals part to whole. Well, we know we have 60 degrees. That's going to be our part. Our whole is, we always know, is 360 degrees of the circle. That's going to equal, that's our central angle there. That's going to equal our part, which is x, we're looking for, over the area section is x of the sector, and our whole is 100 pi. I'm going to reduce. Okay, I'm going to reduce down, and I know that's 1/6. So it's going to equal x over 100 pi. All right, so what I need to do is cross multiply, because I know I have two equal ratios there, or proportion, and I saw proportions by cross multiplying. So I'm going to get 6x equals 100 pi. I'm going to divide both sides by 6 because I'm looking for x. And x equals 52.4. And that would be square units. All right, let's take a look at number 2. Number 2 says, find the area of the shaded sector of circle O. The radius is 6, and the central angle is 100 degrees. Express your answer to the nearest tenth of a square inch. All right, we're going to same setup. So the first thing I'm going to do, I'm going to find the area of the whole circle. So area, again, equals pi r squared. because I'm looking for the area of the shaded. So the area of the hole. So I know that my radius is 6, so that equals pi times 6 squared, or 36 pi. Okay, I know that my angle is 100 and angle, my central angle, sorry, is 100 degrees. So that's going to be, again, part of a hole equals part of a hole. And that's going to be 100 over 360. And that's going to equal, well, x, I'm looking for that part or that sector over 36 pi. I can cross multiply at this point. You can do that, but I'm going to reduce my 100 over 360. I'm going to reduce that to 5 over 18. And then that's going to equal x over 36 pi. I'm going to cross multiply because that's what I do when I have a proportion to solve. I get 18x equals 5 times 36 pi. I'm going to divide both sides by 18. And then x equals 31.4 square inches, or inches squared. All right, let's take a look at number 3. Number 3 says, find the area of the sector with an arc length of 40 centimeters and a radius of 12 centimeters. Now I'm going to immediately go up here to what I highlighted, and it says the ratio of the arc length to the entire circumference, because now I'm dealing with arc length. And I think that's important to point out. All right, so I'm going to draw my circle though. So I'm going to do that. Come on, circle. All right, I have my circle there. All right, and then draw my angle. I have a radius of 12 centimeters. And my arc length, which is here, is 40 centimeters. Now, as I just showed you, I'm comparing that to the circumference of the circle. So the first thing I'm going to do, I'm going to do two things. One, I'm going to find the area of the entire circle. So I'm going to do that now. So area equals, sorry about that A, pi r squared. And then that's going to be pi times, well, the radius is 12, that's 12 squared, or it equals 144 pi. All right, I'm going to find my circumference now. Now I know my circumference formula, Perry pi is delicious, C equals pi d. Okay, so that's going to equal, well, that's going to be pi times, well, if my radius is 12, I know my diameter is 24. So it equals 24 pi. I'm just going to rewrite it the other way. Now I can set up my proportions. So again, I'm going to have part over whole equals part over whole. So I know that the arc length that was given to me is 40. That's going to be over my total, or my circumference, which is 24 pi. That's going to equal my part that I'm looking for, the area of the sector, that's x. And then once again, that's going to be over the total area of the circle, which is 144 pi. All right, so what can we do? We can cross multiply. But even before that, I do that, I'm going to reduce. So I'm going to reduce this to 5 thirds pi. Or 5 over, I'm sorry, 3 pi. And that's going to equal x over 144 pi. So now when I cross multiply, I get 5 times 144 pi equals 3 pi x. I'm going to divide both sides by pi. That's going to cancel on both sides. I'm going to get 5 times 144 equals 3x. I'm going to divide both sides by 3. That cancels. When I put that in my calculator, I get x equals 240 centimeters squared. All right, let's go to number 4. Number 4 is a little different. So it says there, in circle O, diameter AB has a length of 15 centimeters. I'm going to highlight that. And the measure of angle BAC is 65 degrees. I think that's important. It says find the area of sector BOC of the circle. Okay, let's draw what we have here. So I have my diameter, which passes through O, as 15 centimeters, and that's line AB. B, A. All right, so I'm good there. And then it says that the measure of BAC is 65 degrees. So this is BA and then C, because I need another segment to make up that angle, is going to be 65 degrees. All right, so a couple things happen here. One, because I'm looking for the area of the sector BOC, okay, that's going to be actually here. Use a different color and make this bigger again. All right, so BOC, that's that angle that's going to make up this, all right, this sector here that I want to find the area of. Well, BAC, that 65 degrees, is an inscribed angle. So we know that the arc that it intercepts is BC. So that is going to be 130 degrees. Okay, now BOC, BOC here is a central angle. And we know that the central angle is congruent to the arc that it intercepts. So BOC is 130 degrees. Oops, that's ugly. But anyway, 130 degrees. So now I can work because I know I can find the area of the whole circle because I'm going to set up my part to whole equals part over whole. Well, area of the whole circle, area equals pi r squared. That's going to equal, well, pi. My radius, my diameter is 15, so the radius is going to be 7.5 squared. Or it's going to be 56.25 pi. Okay, so my degree measurement, my part is going to be 130. That's going to be over 360, the full degree of the circle. My part is going to be x. That's what I'm looking for, that area. And then the area of the whole circle I just found as 56.25 pi. Okay, I'm going to cross multiply, or better yet, even before that, let's reduce. So I'm going to have 13 over 36 equals x over 56.25 pi. Now I'm going to do some cross multiplying. I'm going to get 36x equals, when I multiply those two together, I get 731.25 pi. I'm going to divide both of those sides by 36. And x equals 63.8 centimeters squared. Okay, not too bad. We just had to draw the picture there just to get a little visualization, that's the word, of what's going on. All right, now, so key ideas. Definitely check your understanding. Questions in class. Video's a little long. Go Cats, go Knights.